So 10.3, evaluate and graph logarithmic functions. The definition of logarithm. So we are right here. So here are two tables of values. And we're going to focus on the first one that we have here. And we're going to create, like it says here, the exponential function of y equals to 2 to the x power, right here. So when x is equal to -2, this is equal to what? 2 to the -2. That would be 1 over 4, because 2 to the second power is 4. -1, 2 to the -1 is 1 over 2. Again, remember, any number to a power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. And that keep going and going, okay? Now we're going to create the inverse function, which is right here. The inverse function means that we can interchange the input and the output, meaning that what we had here as an output is going to be the input here, and you guys can see it. 1/2 was the output, now is the input. Okay. Four was the output here, now is the input. So this table is the inverse of this one. When we said inverse, means that we're interchanging the x and the y. So now, we are going to take a closer look at the second table, the one where we have the inverse. So then, for example, when we have x equal to 8, let me write it down here, x equals to 8. Right here, we're looking at the inverse table. So the x is equal to 8. And the inverse was equal to 3, for example. So here's the question. How is the output of 3 related to the input of 8? Remember, this one was, the input was 3, the output was 8. Now the inverse of this one is the input is 8, interchange, the output is 3. We're looking at this one and we're trying to find why is one related, why is 3 related to the input of 8? So here's the answer. The output of 3 is the power that we have to raise the base of 2. Is the power we have to raise the base of 2 to what? So that we get the input of 8. Right? So 3 is the power that we have to raise the base of 2. 2 times 2, 4. 4 times 2, 8. To get the 8. And let's look at this. For example, we can look at another example. Um, we have another one here too. So let me write that down here. Here's an example. I'm going to give you another example just like this one that we just did here. When x is equal to 1/4, the inverse is equal to -2. And we have it here. So again, the same question. How is the output related to the input? The same question. Of -2 related to the input of 1/4. So here's the answer. How's that related? The output of -2 is the power that I need to raise the base of 2 to get this. The output of -2 is the power we have to raise the base of 2, raise it 2 so that we get the input. It's exactly the same. So I do have, let's look at this again. Sorry. So here's the table. So we have 4, 8, and 16. And we have 2, 3, and 4. So the first one, how is 2 related to 4? Okay, it's related because 2 to the second power, same, the base is 2 to the second power is equal to what? To 4. The base. We're using a base of 2. Actually, this number should be. Mhm. Now, let's do this one. How is 3 related to 8? Because 3 is the base. 3 is the exponent, sorry, that I use, that I raise the base to give me what? To give me 8. Now, how is 4 related to 16? Again, 4 is the exponent that I raised it to get 16. So as we can see, this inverse column that we have here are the exponents of the base of 2. So let me write that down. The inverse column is all the exponents of the base of 2. And this kind of relationship is the definition of logarithmic functions. Okay? This kind of relationship is the definition of the logarithmic function. Here we go. Now, let's go over the logarithmic function. That's the so the logarithmic function is the inverse of the exponential function. So the logarithmic function is the inverse of the exponential function. Forget that is the inverse of the exponential function. So where the exponent, let me write that down. Where the exponent leads to your answer. So this is what we have. We have the 3, which is the base. Okay. Then we have the exponent, that is 4. Right? And that's gonna give us an answer. Of 81. This is the answer. So where the exponent leads to your answer. Now, the logarithm leads from your answer to your exponent, like this. So you're going to have log base 3, here's your base, of what? Of 81 is equal to your exponent, which is 4. So we're using the base. The same base that we use here is the base of the log. And the log of 81 is equal to the exponent. Like they said, it leads from your answer to your exponent. From my answer to your exponent. So now the definition says log base b of a is equal to c. This is, remember, this is the answer. And this means, hold on, base b is equal to the exponent. That's what we have here. The log with base b is equal to the exponent. And this means that b to what? To the c power is equal to a. This is the exponent. This is the base. And this is the answer. So if b is greater than 0 and b is not equal to 1, for and a needs to be greater than 0. and C needs to be an element of all of the real numbers. So all of this needs to happen. This one cannot be 0, cannot be 0, cannot be equal to 1, and C needs to be part of the real numbers. Now, we're going to start practicing, and we're going to go from the exponential form to from this one to the logarithmic form. Okay? So let's try that first. So we're going to go from we're going to practice going from exponential form to the logarithmic form. And vice versa, okay? So we have this part over here is going to say write in exponential form. Write in exponential form. That's the first part. Okay, I don't want that to. Okay. So the first one says up. Log base 3 of 81 is equal to 4. So I'm going from logarithmic form to exponential. So we said what? 3 is my base. The answer is my exponent of 81. Let's do another one. Log base 5. The base is the same base. So here's my base. The answer is my exponent. There we go. Log base 7 square root of 7 equals to 1/2. Okay, base 7, 1/2 is the answer is my exponent, equal to the square root of 7, which they are, right? And 4 log base 3 of y equals to 4. Oh, not 3, 13. So the base is the same base here. The exponent is the answer that we have here, equals to y. Go ahead. Now let's do we're gonna go from the exponential to the logarithmic form, right? Okay, so we have so we said this base is the base of the log, which is 4. My answer is going to be the log of 64. And the exponent is going to be my answer here. You guys see that? Now, 6. So, log base 6. I know that the exponent is going to be my answer, and then this one is going to be the log that I need to find. Log base 5. Again, the exponent is my answer in the logarithmic form of 1 over 125. Okay, and the last one here, 5 to the 7th power is equal to z. This is very weird. So log what? Base pi 7 is my answer of z. So now let's go. Now we're done doing this. And look at this question. What is the value of log base 4 of 16? So remember that the log here is asking for the exponent. So when you raise 4 to a certain power, we need to get 16, right? Let me write that down. It's asking for the exponent. That's what it's asking me. So when we raise 4 to a certain power, we will get 16. So that's going to be log, I don't have it here, right? So 4 raised to the x power is going to be equal to 16, right? That's how we changed from logarithm to logarithmic form to exponential. So what do we have here? And this gives us a what? X equal to 2. So the log must be equal to 2 because it's the exponent of 4. The log must be equal to 2 because that's the exponent of 4 that will give us the 16. That produces an answer of 16. And here comes the examples. Okay, the student. Okay. Okay, so then it says um, find the value of the logarithmic expressions. Okay, the first one is log base 3 of 9. So log base 3 of 9 is equal to x, right? That's what I need to find. So let's go to the exponential form. The base is the base. The answer is the exponent. Okay? So what do we have here? That x is equal to 2. So this is 2. Now let's do number 2. This is base 2. So we're going to do log base 2 of 1/8 equal to x. 2 is the base. X is the exponent. Let's solve this. This would be 8 minus to negative 1, right? But we can rewrite the 8. we can say that will be 2 to the third power. That way we have same base, the exponent are the same. So this is equal to -3. Okay. So log base 49 of 7 equals to what? To x. The base is the base of my exponent. The exponent is the x. My answer equals to 7. We know that 49 to the second power is 7 to the second power is 49. Same base. So that's going to be what? 2x is equal to 1. So x is equal to 1/2. So the answer here is 1/2. Um, hmm, hmm. Oh, let's do this one. So the base is 3. Remember, we said this is x, right? I didn't rewrite it, sorry. 13, 1 equals to x. So 13 to the x power is equal to 1. What is going to be x? If x is equal to 0, it's the only way that that's going to be equal to 1. Any number to the exponent of 0 is 1. Okay, so this is 0 here. Now, let's go and study the properties of logarithms. Okay, let's go over those properties. And based on those properties, we can start doing it. We can practice that. We can simplify it. Let's do it. Functions. This way. So the first property, we're just going to have write them down because hold on. Here they are. The first one. Just like when we were doing the exponents, there are properties for the logs too. So when we have this base to the 0 power, they give us a 1. 3 to the 0 power, we get the 1. Okay, the next one. Base b. b would be my base. To the answer is equal to 2bx. Now, this is equal to log base b of x equal to log base b of x. Now, here comes the product rule. They do have a rule, which is if we have a log base b of x times y, becomes addition. Multiplication is equal to addition. So we're adding the log base b of x and the log base b of y. The quotient rule. Division is equal to subtraction. Multiplication is equal to addition. When you see the division, you say log base b of x minus. Okay? That's what we call the quotient rule. And the last one is the power rule. What happens? This one, we bring it down. That's the power to a power. So we end up multiplying. Now let's practice. So we did all the properties and I have to remember And now we are going to be doing some exercises. That's the practice. The first one says simplify. So we need to simplify it. And here we are, number 1. Log base 5 of 5 to the 4th power. So right away, it's going to be the power rule, right? Meaning this is going to be equal to what? The 4 is going to come down, log base 5 of 5. Now, this is going to be equal to x. Now we said that the base, we just applied here the power rule. That's what we did there. Now, the base to the exponent is equal to 5. That means that x is equal to 1. So the answer here will be 1. The one is to simplify is 1. Two log base 9 of 9. Now let me write the property that we're going to be using right here. Is log base b bx is equal to x. And we have that's the one that we're going to be using here. So based on this is equal to what? To -2, right? Because that's the exponent. Now, let's do this one. 3, 6 to the exponent log base 6 of 5. And we're going to be using, I'll write it down here, b log of bx equal to x. That's the one that I'm going to be using there. So what is it? 5, right? Oops. Just keep all these properties handy. This one is the same one. Okay. Applies the same property. So it's what? 4. So this is for this and for this one. Now let's use the product rule, the quotient rule, and the power rule. Let's use those. What is this one? 7. So we have it says that we need to write they want us to write it as a single ones, okay? So here's the first one. 4, 1 again. So it's log base 8 of 5 plus log base 8 of 3. So what do we say? That addition becomes multiplication. So then this is going to be log base 8 of what? Of 5 times 3. And this is equal to log base 8 of 15. They want us to write it as a single logarithm. We just did it. Log base 5 of 18 minus log base 5 of 6. So we said that subtraction is division, right? It's quotient. So we are log base 5 of 18. What is it? 18 divided by 6. So log, that would be what? 2, right? No, 3, sorry. It's right here. Log base b xy is the subtraction. Division, divide is equal to subtraction. So if I have subtraction, I just divide them. That's what I did here. So here's addition, subtraction, and let's do another, look at this one. Base 2, 1/3 plus log base 2 of 18. So it's addition. So we're going to do log base 2, and I'm just going to multiply. 18 times 1/3, that would be 6, right? 18 divided by 3 is 6. Now we are going to rewrite. So we're going to keep doing example. So this part says we are going to rewrite each expression. So here, the first one is log base 7 x to the 8th power. They just want us to rewrite that. Okay, power to a power, so bring the 8 down. log base 7 of x. I'm done. Because I'm applying, it's right here, the power rule. I brought down the exponent. A power to a power is equal to multiplied. I did that there. Now this one, log base 5 of 7. The same, right? Bring the 1/4 base 5 of 7. Now this next part, it says write as a single logarithm. Okay, so let's do this one. This one says write so it's first we need to apply the power rule, and let me write it down. Okay, the power rule says when I have log base b x, this is equal to the r log base b of x, right? And this is what we call a power, and this is equal to multiplied. Now, so let's use it. So we're gonna do log base 5 4 to the second power, and this one is gonna be log base 5 of 2 to the fifth power. There we go. Now we know this is what? 16 plus 2 to the fifth power. That's 32. Now we're going to apply the product rule. That one says that when I have log base b of x and y, this is equal to log base b of x plus log base b of y. This means that multiplied is the same as adding. So let's apply that rule there. Log base b, sorry, base 5 of what? 16 times 32. That will be what? Log 32 times 16 is 512. Mhm. You see how we're rewriting as a single logarithm, going from 2 to 1 using the properties. Now I have another one. This one is 2 log of base 8 of x minus the log of 8 base 8 of x plus 3. Right away, you see a subtraction, you know it's going to be a division. But first, look at the 2 here. So we need to use the what? The power rule, right? So for the first one, right there. So right here, we use the power rule. I don't think I need to write it down, guys. Oh, you might. So it's r log base b of x. Now, we're using the quotient rule that we use the product, we're going to use the quotient. Subtraction log base 8 x to the second power divided by x plus 3. And this is what we call quotient rule. Okay? And it says that if I have log base b of x over y, this is equal to what? X minus the log of y. So division is equal to subtraction. Mhm. Now let's do this one that has more than one term. I mean, it has 3 logs. Mhm. We are on 10.3. Mhm. Um, this one. This is log base 7 of 12 plus log base 7 of 5 minus log base 7 of 4. There we go. So it's a cube. So first, I'm going to do this 2 first. What am I using here? The product rule. So it's going to be log base 7 of 12 times 5 minus log base 7 of 4. And right here, right on this one, I use the product rule. Okay? Again, log base of xy is the same. I guess the more I write it, the more I remember. I just realized that. Now we have a subtraction, right? So that's going to be a quotient rule. Log base 7, 12 times 5 is 60 divided by 4. And that's what I just did there is what we call the equation rule. Okay, log base b x over y is equal to the log of x minus log base b of y. And what do I get here? 60 divided by 4 is 15. Okay. Couple more. Okay. Hang in there. This one says write each expression and sums or differences. Okay, so we have the first one here. It says log base 5 4 times 3 divided by 7. Oh, it's a combination. Okay, so first I know it's a multiplication, so it's going to be an addition, and the division will be a subtraction, right, guys? So it's going to be log base 5. The multiplication is an addition, and the division is going to be a subtraction. And we are done. Because if you go back, this would be 4 times 3. Okay, let me just show you this really quick here. If we take this 2, which is going backwards, would be 4 times 3 minus log 5. And this is going to be what? 4 times 3 divided by 7. And that's what we have there. Okay, so I don't even need to show you that. And look at this one. Log base 4, a to the second power and b to the fifth power. We have a power to a power and a subtraction, right? So let's bring the 2 down first. Now, oh, and the 5 too. So bring the power down, power to a power, and division is subtraction. And take a look at this. This would be what? And subtraction becomes to the second power by b to the fifth power, which is the same thing that we have there. Okay? Let's do this just last part. It says if the log of base b of 5 is equal to 0.83, right? and the log of b, base b of 3 is 0.56, use the properties to evaluate. Okay, so the first one is this one, log base b of 15. So we know that this is equal to what? To 5 and 3, right? So log base b of 5 plus log base b of 3. So what I'm doing is 0.83 plus 0.56. This is 1.39. I just replace it. I'm using the values that they're giving me there. How about this one? Okay, I know that this is what? 5 and 5. So log base b of 5 plus multiplication becomes addition of 5. So I have 0.83 plus 0.83. That's going to be 1.66. And the third one is log base b log base b 3 1/2. So what do I do? I'll bring the 1/2 first. So I know it's 1/2 and I have this value, which is 0.56. And this is equal to 0.28. This is the end of 10.3.